I know we only have 25 minutes, so some of this might be a bit rushed, but either way, I'm going to do this. If you have questions, feel free to hit me up on Discord or over email. It's usually the easiest. And yeah, let's get going. For those who are not familiar with what a money market is, I pulled up a simple money market. This is not on Bitcoin. This is actually one running on Solana, a competing chain, we could say. But I think they make the UX really easy, and it's very easy to understand. So generally what you do on such a money market, an on-chain money market, is you deposit assets. On those assets, you earn a little bit of yield. And against those assets, well, you can use them as collateral. So against them, you can borrow other types of crypto that, several other people have deposited. And so, for instance, I'm not connected with my wallet, but I could connect my wallet and then deposit, say, I don't know, wrap Bitcoin, which is not that great, right? Wrap Bitcoin, we will soon on stacks of SBTC, but imagine the same, and you could deposit SBTC, which is like nearly identical to BTC. So you could deposit that. It automatically, through an Oracle solution, figures out what the current price is of your SBTC, and it creates like this little health score. And then against that, you could, for instance, say borrow USDC. You could see the borrower rate in real time. This is usually a dynamic borrow rate, by the way. So if you're using such platform as a user, be careful, because this is alongside what we call a bonding curve. So today, not many borrows are outstanding. Only 76,000 USDC is being borrowed. And that's why it is pretty cheap to borrow today, the USDC. But imagine this goes up a lot, and you can see the ratio, right? There's 640,000 deposited in by users, earning a tiny yield, 7 basis points, but only 1/10, about a bit higher than 10% is borrowed. And that's why, again, the interest rate is kind of low. But imagine this goes closer to whatever gets deposited or was deposited. Imagine 640,000 is now borrowed. The interest rate would shoot up, and that is to incentivize people to pay back their loan, right? Because else depositors, they would get into trouble by not having access to their own deposited crypto. And that's like this little bonding curve, the incentive mechanism, where users who have to pay too much interest rate would pay back versus, not paying back. And so I think that's all there is to it, in my opinion, at least the basics, right? There's a health score. If you start borrowing, the closer you get to liquidation, obviously the lower your score. And it's about depositing and assets and borrowing against them. And so now that we know that, I'm going to just dive right into Clarity. And Clarity, for those who are not familiar with it, it's the smart contract language, the programming language of Stacks blockchain. It's a really cool little neat language. I love using it. And whenever we start a project, let's just think more of like in terms of user stories, what a user should be able to do, right? As a user, let's say I need to be able to deposit SIP10 tokens. And a SIP10 is simply a crypto asset on the Stacks blockchain. So I need to be able to deposit that. I need to be able to borrow against my position, my deposits. I need to see my health score. So I'm sure you can, envision tons of other, user stories. There might even be other personas, like as an admin, but let's start with those three. I have never implemented that today, so that's going to be a fun exercise for me right now too. And let's see where we get. So I have an open repo, by the way. It's called Sticky, and Sticky is an LSD implementation that I did in my free time. It's not live, it's not public, the code, but if you're building an LSD on Stacks, feel free to hit me up. Always happy to share my feedback and whatnot on what I learned building a really quick prototype of that liquid staking derivative on Stacks. But today we're building a money market. So let's start with the core. A core contract. So I'm going to create a new file in my contracts folder. I'm going to call this, say, I don't know, SIP10 reserve or token reserve .clar. .clar means .clarity, so that's the extension. And I'll be doing quite a lot of copy pasting to make it a bit quicker. So for instance, first we're going to define what I call a constant. If you don't have program experience at all, some of this might be a bit confusing. I'm not going to explain every little bit, you know, what a variable, what a constant, what a function, what a public function, all those things. I assume you have that knowledge, but let's just go there and you can look it up on Google online if you don't understand what a constant is, but that's basically a variable that can never change. So that's an error code, not authorized 401. And then we're going to define a map, for instance, define map of our deposits, because I'm going to start with this one. As a user, I need to be able to deposit SIP10 tokens. And a map is simply, what a map is usually in a language is it's a key value store. So it's a very efficient mechanism for, to save data. It's like a data structure. And in fact, now I was already thinking we have deposits, but are these user deposits? Yes, they are user deposits, but should a user be able to deposit anything, any crypto token, even like a dumb shitcoin that I create? And no, we probably don't want this. So how do we protect against that? And that's obviously up to you as a user to decide. Do you want a DAO to govern a whitelist, or do you want as an admin to choose this yourself? So we could say, as an admin, I can add a new depositable SIP10 token. And I think actually let's implement this one first. So I'm going to say, call this whitelist, whitelist. And what is the whitelist? It's again a map, a key value store, where we say which asset as the key. So that's an address, it's a principal, that's called a principal typing clarity. And then we're gonna say whitelisted is a Boolean, I believe it's called, bool. And so we can set that to true or false. The way we can then ask whether a specific, address is whitelisted or not, we can create a getter function for that, and that's a real-time, a read-only function. I'm just going to copy paste one here, and I'll explain the code so we go a bit quicker, right? Usually, I also divide this up into, maps, read-only functions. So I'm going to paste that there, and I'm gonna say get is whitelisted. Whatever you want to call this, maybe you want to prefix all your getter functions with get dash. It's up to you. As a input parameter, we again use that address of type principal. If you're a bit confused by all the braces, by the way, don't worry, that's clarity. Initially can be a bit confusing, but you'll get used to it. And so so here we're going to do a map get. That means we're going to look something up in that key value store. And so in our whitelist, we're going to look up the address, basically, in the map. If it's not found, this default to thing will be called, and then we'll return false, whitelisted false by default. And so now we can use this little get is whitelisted function, to use that in one of our future function definitions. And so now we can get started. Let's say more or less we have this done. Obviously, we need to protect that, right? So we need to define a public function at whitelisted token. We again need one parameter, and there we do a map set, but we will have to protect that, which I'll show you in a bit. We do whitelist address, and then we say whitelisted true, or something like that. Or we could add a toggle function or whatever, because maybe we want to blacklist some tokens later. But yeah, this is the basic of the basic. And so if you think about this, once we deploy this to mainnet or testnet, anyone could call this, right? And that's why we have to protect this function, and we can protect that with an assertion. I'm going to look one up here, and I'll explain again what this does. So asserts means we do an assertion, and we say the transaction sender, that's a reserved keyword in Clarity. It always knows who that is. So if you use tx-sender, it automatically resolves to the address that is calling the function. Contract owner is not a reserved keyword, so it will look that up. And currently we don't have a contract owner, so we would have to create that. And if you see here in this file, I also already have this defined. So I'm going to just add a constant contract owner, and this gets actually initialized. Again, remember, a constant can never be changed. It's immutable once deployed. So this gets initialized once the contract gets deployed. And so the contract owner will be equal to the transaction sender. And the transaction sender is the one who deploys the contract to mainnet. If you want to make this changeable, you can define a variable instead of a constant, so that then later you could change that. But again, that implies that your contracts might not be as decentralized or as immutable, because you could change the owner, and then maybe the owner has some other permissions, such as maybe they can withdraw assets or whatever, right? So you need to think about all the implications there. And so in this case, we say only the contract owner can call this function. If it's not equal, is dash equal, if that returns false, we throw this error not authorized. And again, here that was a remember where we defined that as a 401. Then it throws that error 401. If this succeeds, this assertion, it continues code execution, and it sets the address to whitelisted true. All right, awesome. I think we have a pretty good idea of what the admin can and cannot do so far. As a user, let's continue with this one then. I need to be able to deposit SIP10 tokens. We didn't have that deposit map yet, so we're going to continue on that. Let's think about this for a second. How do we want to define that data structure? And again, in any implementation, there are always multiple ways to implement something. The way I would do this is I would create a map, a key value store with two keys. So it's like a composite key. And one would be the address of the asset. So let's call this, I don't know, crypto asset. It's not the best name, but it's just for purposes of this demo, call it like that. And that's the address of the whitelisted asset. And then second, we would have maybe call this dash address, and then user address principal. And then we would keep the amount that they have deposited, which is an unsigned integer. Alrighty. And so again, we can, define a read-only function for it, get deposits for assets from user, whatever you want to call it. Then we need two input parameters, because this has two parameters as well. So the crypto asset address and the user address, which are both principals. We define the function. This won't work, by the way, I see now. I forgot to return something with it, and I'm going to do any public function, by the way, needs to be returned with OK. Sorry, that was something I missed. If I would try to compile it, by the way, or try to run it, it would throw that error anyway, but because this is just pseudocode. But let's continue with the read-only function, get deposit for asset from user, and then we're going to do that lookup. This was in fact wrong. I don't need a begin block. I need a default to block. The default amount would be 0. Oh yeah, by the way, any the uint I didn't tell you this, but the uint is an integer, but an unsigned integer. And unsigned means only positive numbers, so 0 and above are supported. So you cannot pass anything negative. In fact, Clarity does not have negative numbers. You don't really need those in generally when building code. And so if the default to is called, we return the amount 0. And yeah, by default, we're going to do a lookup here. I'm not sure because I gave them the same name. This will fail, but again, this is some pseudocode, so it doesn't matter, but we're going to do that map lookup. And so now we have a read-only function to see how much was deposited by each user. But we obviously need to, to write a function that can actually deposit assets. And we're going to pass, again, well, only two parameters in this case. The crypto asset address, which is a SIP10 token, and the amount, which I think this is, I'm not sure if this is correct, but here we do need a begin block. And then we're going to try to transfer the token. Every token, every SIP10 token needs to follow a certain standard. And on stacks, that's the SIP10 trade standard. So any token that exists on the stack's mainnet, whether that's the Deco token or some other fungible token, that has the transfer function implemented. So we're going to call that. I need to think how the syntax was. Contract call, and then on the asset, crypto asset address, because that's a principal we passed in. So we should be able to call that. And then we're going to call the transfer function with the amount. And we're going to deposit that inside of this address. And the way we can deposit that in this address is by fetching the address of this deployed contract. And we get that using scontracts txsender. This is a bit confusing at first, but it's just what it is. If you need to learn more about it, look it up. And I'm going to wrap this in a try block or a try invocation. And it just tries to execute this function. If that fails, it just halts and it quits execution. What you should know about smart contracts is that any execution is atomic, meaning if one or more things fail in function execution, the whole state gets rolled back and nothing gets executed. So imagine I transfer 1 million tokens of something, and then I do something else. If that something else, that second thing fails, my tokens won't be transferred. So you know that this is like a nice atomically isolated whole. So that's that. Obviously, we added a whitelist, and we're not checking the whitelist here. So we need an assertion. And this is where our get is whitelisted read-only function comes in handy. So we need to, again, this is pseudocode. I might not have the exact right thing, but get is whitelisted with the crypto asset address. And this actually returns a hash. So we still need to get the whitelisted. I think it's this order. We still need to get the whitelisted value from it, which is true or false. So as a whole, this command will return true or false. So the assertion, if it's true, it will continue. False, it will throw this error. Same logic. And we need to return, okay, true here at the end. And so now we have deposits. I think I'm running almost at time, so this is just some basic logic. But if let's just for a second, for another minute, go through some other user stories, not actually implementing, but thinking of them. Need to be able to borrow against my position, which is a second big user story, right? But to know how much a user can borrow, we need to get the dollar value of whatever they deposited. So imagine I deposit 1 BTC, which is approximately $30,000, and we say generally the loan to value of borrowing against BTC is, let's say, 50% for easy calculation. Then I should be able to borrow $15,000 worth of assets, whether that's USDC or maybe Alex or Tico or something else. That's to be defined. Whatever is available, right, on the platform, whatever is whitelisted, we could borrow in dollar value technically. And so again, if you would love to know more about this or have some questions, feel free to get in touch with me. I know this went really fast, but yeah, in those 25 minutes, that's all I had, and I hope it's been insightful. I'm gonna give it back to you, Albert, maybe for a closing question or whatever you want to do, but thanks for having me, and I hope that this was interesting to all of you.